Hey, my name is Francisco. I'm a software engineer at the New York Times, but I'm not here exactly to talk about my work at the New York Times, but my work at the company that I worked in Brazil before. So I just moved here. It's a nice country. We have great subway. You guys have like great elections too. It's nice, much nicer than ours. Yeah. I'm going to talk about Tsuru and also a bit of the history of Tsuru. That's a PaaS that started back in 2012. And it started using Docker in 2013. So it's kind of older than Docker and how to work it out. Let me just introduce myself properly. I work at the New York Times as a software engineer in the video area. So maybe if someone is interested in talking about distributed computing with Docker or transcoding videos with Docker, I could have added this here, but we can talk about it. I'm also a Docker captain, probably the least active one. Who here is familiar with the Docker captain program? It's kind of Microsoft MVP, but for Docker. So I have some experience with Docker. I hope I can help people in one of the sessions as well. And I'm trying to get up to speed with other captains. I'm one of the first developers of the PaaS that I'm going to show you today, and I used to be a more active open source contributor, but moving is hard, I would say. So what's Tsuru? So Tsuru is an open source PaaS. Has been created by Global.com, which is a media company. It's part of the largest media group in Latin America, which is Global. It's used by other smaller companies in Brazil. It's also used by the largest Brazilian university. And there are some other companies around the world using it. It's fully open source, everything. The company doesn't try to sell it because it's not part of the business of the company. And we tend to say that it's like real life, production oriented from day zero. It was very pragmatic. So there are it is a good character, but there are some downsides to it. Let me just show what it is so people can have a feeling. Who's familiar with Heroku, OpenShift, and most other people? So the way I prefer to interact with Tsuru is from the command line. So I can create my app and deploy it, and I have it running on my laptop, but I can have it running anywhere else. The way I created the setup for me, I just ran Tsuru install. I'm not running now because it's slow. It takes some time to set up everything. So if I want to create an app, I need to first decide which platform my app is made of. So if it's a Python app, I would say I would use the Python platform. So in this setup, I have Python and static. Static is just like an Nginx serving whatever contents I want to deploy. And this is the one I'm going to use. So upgrade, I will call it, I don't know, hello containers. And I will say that it's static. And I also need to specify which team owns that. I did that, I create that. And what Tsuru does when I ask you to create an app, it doesn't do much stuff. It creates a host name for my app, which I can just open in the browser, and there isn't anything yet because I haven't deployed any code to it. And also there are some information that makes more sense after you get up to speed with it. There is also the possibility of having a Git repo where you can git push your code just like with Heroku, but in this setup this is zero. Just for simplicity. And I can deploy my application. Hello containers. So this will upload whatever is in my client folder, and I have an index.html file here. It will upload to the server, and then the Tsuru server will create a Docker image for my application on top of the platform image and launch my container based on proc files. It's just that in this case I don't need to specify the proc file because it's a static application that I just want to run. But if it was like a Python application, I could have a proc file specifying how to start my application, just like you would do in Heroku. If I refresh on the browser now, it says something like hello ContainerDays New York City, which is nice, but yeah, people have been doing this for a while. I can also do stuff like scale my app. I can add a new unit to it, and this will use the same Docker image that I use in my deployment, and just install a new container running. So if I will just refresh this. A nice feature is that it supports to, during the deployment, I can check the health of my container and only send traffic to it when it's up. So how would I expect that? So I have a Tsuru YAML file, and I want to have the health check on this file that doesn't exist yet. So let me create this. Okay. And if I deploy it, now we'll see an extra step in the deployment, which is checking the health of each unit. And now that I have 2 units, the deployment will replace both with the new ones. So you see that there is a health check failure here because the container wasn't ready to accept new connections yet. So Tsuru retried it, and once the health check worked, it added routes to the units, and this means that it started sending traffic to the units. So at some point I had 4 units, 2 old units, 2 new units, and then after traffic is working with the new units, I can destroy the old units. And that's what it does. Let me see my here. Yeah, and health check will be used whenever I want to create a new container. So, hello containers. If I want to create a 30 unit, load. It is going to health check the new unit until it works, and then so. At Global, what did we recommend to teams using Tsuru? We would say, please have on your health check some piece of code that ensures that your app can run. So if it depends on a database, you just try to connect to that database and do some operation on your health check. This is not health check for monitoring. This is health check for ensuring that your application can receive traffic. It's ready for traffic. Yeah, and it has other stuff that PaaS has provided, like logs, and I can follow the logs if I want. So if I send some new requests, I'll see them showing up in the logs. Another nice feature is swap. So let me show this if I can very quickly. I'm going to create a new application. I'm going to deploy the code to this application. So, but before deploying, let me just say. Oh, when I created, okay. Let's use the wrong one. So I will deploy, and then suppose you have like 2 different versions of the same application, and you want to release a new version, and you want to try real traffic on it, so you can swap the routes of these 2 versions, and if something goes wrong, you can swap back. So this is what swap will do, and there's a warrant because I have 3 units in one application and 1 unit in another. So are you sure you wanna, suppose you have production traffic and you need 40 units for that. And you're swapping your non-production traffic to 1 unit only. Are you sure you wanna do that? I mean, in this case. So if I refresh now, it says that I'm at Juju. And I can also open the one with the wrong name, and it says, it doesn't say anything, which means F1. I can swap back, and then it swaps the routes. Yeah, so one of the apps is the dashboard. I will show this really quick and we will go to. So one of the apps running on my Tsuru installation is a dashboard that allows me to do pretty much everything that I can do on the command line. I could go here. I think even deployment, I could upload code here, I'm not sure. No, I can't. Yeah, I can't deploy, I need the command line to deploy it, but I can view logs from an app, for example. So if I just go here and hit it, I'm seeing view logs, it's just that it was exactly the same. Now we have a 200 here. I can see events related to that application. I can also see all events that are happening in the cloud. So here. And the idea is that the Tsuru server is an API, and there are 2 official clients for this API, the one that you use on the command line and the dashboard. So whatever one can do, the other can too. Sometimes they are out of sync, but whatever one can do, the other can do too. If you want to play with that, you can install Tsuru, run Tsuru install, and start using it. But how did we get here to this point where we have this PaaS that is used by some applications at Global and other companies? So back in 2012, in January 2012, we had like some directory platform that decided, oh, let's move to the cloud. And what is that? Global has its own data centers. It doesn't use any public cloud. In fact, at the time, they were planning to build a new data center, so there was no chance that we were moving to a public cloud. So let's go with private cloud. But what does private cloud mean? For us at the time, it means we needed an IaaS, and we also wanted to build on top of this IaaS a PaaS for our application developers to easily deploy their application. I don't hear these terms that much anymore. People talk more about containers these days, but you still need this kind of stuff. And at the time, we decided to investigate OpenStack at the IaaS layer and Cloud Foundry at the PaaS layer. Global ended up with CloudStack. I just wanted to mention this. I won't get into details why they chose CloudStack over OpenStack at the time. But I will talk about Cloud Foundry. So we had some issues with Cloud Foundry, and most of the issues were related to governance, non-technical issues. And I don't want to get into the details because I'm sure Cloud Foundry governance has changed since 2012. It has definitely changed because it used to be a company owned with some issues, and it's now a foundation owned project. It's better shape, but it wasn't at the time. So what did we decide? We decided to create our own PaaS. So there was no Docker, there was no other tools to help us starting. So what was it to create a Docker, a PaaS in 2012 with no Docker? So most of these industry standard PaaS used containers. So Heroku used containers, .cloud used containers. Actually, Cloud Foundry and OpenShift at the time they had user level isolation, but no file system namespacing, which was kind of bad. If you install a version of a dependency, it affects all apps running the same host, for example. But we decided to go with VM because that's what the knowledge we had at the time. And at some point we would investigate containers too, because we knew that that's what we needed. We decided to go with the Go programming language too, which was kind of crazy in 2012 because they didn't have a stable release yet. So we were like surfing the bleeding edge. We started with Juju. Has anyone heard of Juju here? Does anyone use it? They say they are DevOps distilled. I don't understand what it means after 4 years. I don't know. So so they have what they offer is facilities to deploy anything anywhere, basically. So that's why it's hard to define it. But at the time they had like very specific goals, which is we automate your cloud. So they supported EC2. They promised to be agnostic at some point, but at that time they supported EC2. But it worked out because we were trying OpenStack, and OpenStack had a compatibility layer with EC2. If you ever use it, you wouldn't recommend it, but we tried it. And it kind of worked for us. And at the time, Juju had the way Juju worked wasn't ideal. It had like this bootstrapping instance for each deployment. And each deployment is a service that you have. And basically, they use Zookeeper, but with a single master. And if you lose your bootstrap instance, basically your work ends. I remember that we lost one, and we posted on Juju RSC. We asked it, what happens if we lose the bootstrapping instance? And they were like, the work ends. And that's what happened to us. But we recovered it. But we started with it. So I mentioned platforms, application, and units during the demo. So how did it map to the Juju world? Each platform was a Juju chart, which is a set of rules that you want to provision your service with. The application was a Juju deployment, but also a load balancer. And we only added the load balancer when we temporarily gave up on OpenStack, so we went with ELB for a while. I'll get to that. And each unit was a VM, so we had one VM per unit. So you can imagine that unit add command taking like 10 minutes instead of 2 seconds, like it did. So if we forward to December 2012, we deployed the first application to production with Juju on EC2. Because we were kind of transitioning from OpenStack to CloudStack, and we didn't want to wait until they decided to do it. And we were like, okay, just give us a credit card and let's run on Amazon while you figure this out. And give me an EC2 API afterwards. They never gave it to us, but we adapted. The interesting is that we had like 10 minutes overhead for deployment, for unit creation. This was 10 minutes overhead per unit. So you imagine you have an application with 20 units. We would do it in parallel, but it's still slow. So if you deploy, it would replace all your units, and it would take 10 minutes of overhead. If your build process is like 20 minutes, your deployment will be 30 minutes. That's much better than what the company had before, because there was a process to get to production, and the overhead of this process was like 2 days probably. So you finish your code, you need 2 days to get into production, and then we were like 10 minutes. But yeah, we want to do better. That's not as good. That is not good. But 2012. But what's the answer? Containers. We need containers. But that is still December 2012. No Docker, at least not public. But we were happy because Juju supported LXC. But they said that it was development mode only. Not that we cared, because we started using Go in 2012, we started using Docker in 2013. So if someone says that you can use something in production, we don't care, we try it. If it works, we use it. But the problem is that it wasn't designed to be used in production. It wouldn't work in production. So let's do it ourselves. So that was our plan. That's how we ended 2012. We are going to build our container orchestration thing in 2013. If we fast forward to PyCon 2013, this happens.
So if I want to run echo hello world in BusyBox, and I want, by default it'll run in the background, so I'll just say -a attach. So what had just happened here is it generated a new LXC container, allocated a new file system for it, mounted a rewrite layer, allocated a network interface, set an IP for it, set netting for it, and then executed a process in there, captured its output, and printed it to me. So that was all. I can do it a bunch of times.
Awesome. So we saw this video, we're like, oh, we need this. We want this, we want to run this thing. And that's definitely the case. Docker has changed the game for containers. So before that, and I recommend that you watch this video, the full video. Solomon explains that they had kind of some kind of LXC orchestration, but it wasn't very structured. And they decided to restructure and create Docker. And I would say that Docker has definitely changed the way people approach containers after this presentation. And the title of the presentation is like the future of Linux containers. It's just perfect. So after Docker changed the game, everyone started creating their own PaaS. So this is a very smart guy. I recommend you to follow him. Everyone started creating, and this was October 2013. And I would say that between March 2013 and October 2013, I saw like 10 new PaaSes showing up. And also the old PaaSes started coming up. Like Tsuru decided to move to Docker, OpenShift decided to integrate with Docker. Cloud Foundry kind of have something integrated. They took longer, but today they also moved it over to Docker. But the nice thing is that October 2013, we were running Docker in production, and it was Docker 0.5. Don't believe. So we decided to integrate with Docker, and this is how the concepts are still today with Tsuru. So the platform is a Docker image now. The application is another Docker image using image layering. So it's a layer on top of not one layer, but some layers on top of the platform image. And each application also has a host name that sends to this, what we call a router, but it's actually a proxy, a reverse proxy service. Instead of having a load balancer for each application, we have a general reverse proxy service. And each unit is a Docker container, so that's why unit adds 2 seconds, sometimes 1 second, instead of 10 minutes. So another December, another application launched into production. In October, we had Docker in production, but we didn't have any user-facing application running in production. But in December, with Docker 0.7, we had a user-facing application running in production, which is cool. Just a brief jump to 2016. So Tsuru today has like 800. It always changes, so it's probably not today because I left the company in January. So I kind of talked to them to share these numbers. They have 800 apps, 300 deployments every day, and they run all kind of apps, from internal worker-only applications to applications with peaks of 400K simultaneous connections running, which is cool. And what Tsuru provides is not the scalability. It provides a nice infrastructure for that, but they can move fast with these applications. So with the old process, having 800 applications with 300 deployments a day was just impossible because it didn't scale. You needed someone to press a button to get your application in production. Now you do it yourself. So what was it like to run Docker in production in 2013? I actually have a VM with Docker 0.7, and it is on GitHub, Joe, if you want to try it yourself. So Docker didn't change that much if you think about the basics. They already had images, but if you get Docker 0.7 today, you won't be able to run a Docker pull, and I'm not going to run it because it fails with segmentation fault. Because Docker has changed the API of the registry, so I can run Docker pull of this. I can try, let's see. I can restart the server afterwards. Do we have internet connection? Okay. This is definitely not going to work because they have Docker registry API v1, and now they have v2, and v1 no longer exists. But I have an image, and if you want to try it yourself, you can run a container on a newer version of Doc, export that container to a tarball, and import in an old version of Doc, which is nice that it can still do that. So if I want to run my image, I can just works just like it used to work. What? Yeah, so I have bash. I can run, I don't know, just like it did. Hello world, I can run Vim. I don't have Vim, I can install stuff if the internet works. And that is fast. Let's see, it doesn't take much longer. We can do it. No, that's just low. How many packages do you need to edit the text file? Cool. I feel like this is going to work. So yeah, I can have Vim, I can have a Python script, because Python is the dependence of Vim. So, I don't know. Which is also cool that I also could generate an image out of this container. So this one, if I want to generate an image, I can commit this container. And I want to create a Vim container, so I can do this. Use Docker build, don't do this. And if I get everything right, this should just work. Yeah. So I run Vim inside a container with Docker 0.7. Yeah, Docker build also worked, but if you check the syntax for the Docker file, a bunch of stuff changes. And there's one nice thing coming from Docker, from next version of Docker with Docker build, which is Docker build. And I forgot the third, but you can just join. Yeah, it's dash squash. So you can Docker build squash, and you have a single layer with everything. Before that, you would need to export your image and import it back to have a single layer, which is cool. But this is coming with Docker 1.13, and this is from this time. People were asking about that, and I'll show you why people were asking about that. So what were the challenges in running Docker 0 something in production? in 2013. So upgrading Docker was a pain. It was just terrible. At first we started, okay, let's try upgrading in place. What happens? All containers start never started again. So let's define a process that is more safe and people should do it all the time. You launch, if you have cloud computing or if you have some kind of facility to work with that. You launch a new node with the new version, you move containers over, and you destroy the old one. But at this point, Docker was breaking the image format somehow. But sometimes you couldn't just move a container to a new version. It wasn't compatible. That's the thing you get when you run before 1.0. All AUFS bugs. Who have run AUFS in production here? Yeah, no one, because when Docker 1.0 was out, they had dropped it. That's a great idea that was poorly implemented, or someone didn't give it enough love. It was full of bugs. I remember that with 42 layers, your Docker image would stop working, but it wouldn't fail. You would just start losing some files from old layers. So at some point, people figured this out, and Docker would panic on, would fail for yourself, for your application at layer 42. Why 42? And it's the magic number. So that was crazy. But yeah, there wasn't much stuff to do. Docker solved this issue by just dropping AUFS. And I want to talk more about integrating with Docker and scaling. And when I say integrating, it's from our code, how we communicate with Docker. When Solomon did that presentation, Docker was just a command line, and it had the daemon mode and also the non-daemon mode, which is the way Rocket works these days. Docker has dropped the non-daemon mode, where you could just Docker run and it would create a process right away without communicating with any daemon. This day, Docker supports on the daemon mode, but at the time they had a private API. And I think on Docker 0.4 they decided, okay, let's make this an HTTP API and document it. And the nice thing is that we use Go, and Docker is in Go too. So we can probably use their clients, but not really. They didn't want to provide a client for their API because they were sure that they were going to break their API, and they didn't want the burden of maintaining a client. Why did we decide to go? To create a client and had the burden ourselves. And it was crazy, very unstable API. The good thing is that these clients ended up being used by other PaaSes because people decided that they would use Go and Docker to build a PaaS. So OpenShift at some point used this client, and Kubernetes at some point used this client, and then Docker came with the official client. And I would say if you're starting a new project, use the official client. If you're not starting a new project, if you have to deal with this, we still maintain it and we make sure that it works because we still work. We still use it. And another problem with upgrades is that the API was all the time changing. Even though they had API versioning, it didn't work before Docker 1.0. And it wasn't supposed to work. It was pre 1.0. We were aware of that. And yeah, the other issue is scaling. We knew that we had like website with 40 to 50 million daily users, and we knew that we needed to scale if we want a user-faced application on Docker, on Tsuru. No Swarm, no Kubernetes, no Mesos. People were running, everyone was doing this secretly, so we decided let's create this and let's open source this library. And the funny thing about Docker Cluster that it is a library, it's a Go library, so if you want to use it, you should not use it, you should use Swarm. You should use Swarm, Kubernetes, or Mesos this day, but if you wanted to use it at the time, you could just use it as long as your software is in Go. And it would talk to the remote API. And it supports almost everything Kubernetes, Swarm, and Mesos supported like 1 year ago. It's very specific to Tsuru use case. You can create pools of applications, and you can deploy your containers to these pools, but it's not as powerful as and as extensible. But we had, in 2013, the idea that, oh, we want to add a daemon in front of this API, in front of this library, and this daemon will implement the Docker remote API, and then you can use the Docker client, the Docker command line tool to talk to this API, thinking that you are talking to a Docker daemon, but actually you are talking to a cluster. And you could have a cluster API managing other cluster API. And this is basically what Swarm does. So yeah, 2 years later we gave up and said, this is Swarm. But this was really just an idea. We were never going to get there, because that's not our product. That was never our product. And another challenge is, how do we isolate containers? There was, again, no solution available. That's the bad part of being early adopter. So we didn't decide to build anything on that. We just decided to leverage, because we were running on cloud computing environments, we decided let's leverage VM level isolation and make sure we created application pools. It wasn't never clear the rule to create an application pools. Sometimes each pool is a business unit, but there are some business units that have different kind of applications, and because of that they would have multiple pools. And there are some pools that have multiple business units, but if two applications couldn't share infrastructure, we could ensure that. But through VMs, not through containers. And where is Tsuru and Docker going now? So Docker itself is shifting towards orchestration. And I know this is polemic, because people are like, Docker shouldn't do this. Docker should be like Rocket and another tool. So people are kind of not 100% happy with this. But Docker is shifting towards orchestration, because the community is shifting towards orchestration. So we have Kubernetes, we have Mesos, and we have Swarm, and we have also Nomad from HashiCorp. And these are big things. And the next step for Tsuru is definitely to drop the cluster management library and use these tools that are available in the community. And they are working on that, I'm sure they are. I think they started with Swarm. I don't know why, but they are working on everything. Not everything, all these three. Talking about Kubernetes, I am told that the New York Times is looking for people to work with Kubernetes. The New York Times is looking to move to Kubernetes in production with Google Compute Engine. So if you are interested, just talk to me over the hall or something like that, or just go to this link. But yeah, it's better if you talk to me, I suppose. And also, if you want to try Tsuru, if you want to play with it, you can do we distribute binaries, precompiled binaries for Windows, Linux, and Mac. And there are also standard packages for Ubuntu and Mac. I would say Ubuntu is not standard, it's almost standard. And then after you install Tsuru, you can just run Tsuru install, and you will leverage Docker machine to create everything on your local. And you can also configure to point it to Amazon or something like that. If you want to play with Tsuru, you can go to github.com/Tsuru and see every project that are there. You can contribute if you want. And I'm available for questions. You can drop me some email, and that's my SlideShare profile where I'm going to post these slides. If anyone has any questions, I think I have like 5 minutes. Thank you. No questions?
Swapping deployments back and forth. Say the deployments were like a dynamic web page, and how would that handle what's already in cache? Does it flush it?
So yeah, so that Tsuru YAML file where you specify the health check, you can also specify some hooks that Tsuru is going to call when something happens. So it's up to the application to call like the deployment hook. I need to run a migration, for example. So, and there are some hooks that Tsuru guarantees that it's going to run only once, even if you have like 40 units. And there are some hooks that runs for every unit. So when it rolls back, you can do your whole rollback hook. Any other questions? Yeah, just reach me on the hall if you have questions. If you want to see other stuff on Tsuru, I can show on my machine too. And I can also show that dashboard, an actual dashboard for an actual production with some metrics and other stuff that I couldn't show from my local host and I couldn't show to the camera. Thank you.